Welcome to drawing inferences from the givens. So today we're going to be talking about a diagram, looking at it, and reading the question most importantly, and what can you determine based on what's given. So we have some terms here that some of them you've seen before, like perpendicular bisector. You know that it's just a line, ray, or segment, right? And all it does, it intersects to create a 90-degree angle. It creates a 90-degree angle, that's the perpendicular side. But then we also have the bisector side, which means that if you have this segment AB here, C will be the midpoint. And that's the part that says bisector, okay? Perpendicular bisector does two things: create a 90-degree angle and creates a midpoint. So let's look at median of a triangle. The median of a triangle says that there's a line segment drawn from the vertex of a triangle. So what do we need? Yes, we need a triangle and we need a vertex. So let's call this triangle ABC. Here's my vertex at B. It could be A, B, or C, but there's one of the vertices. And then you draw a segment to the opposite side. And there we go. That means that this point here becomes the midpoint. And let's call that point M for midpoint. That's all the median of a triangle is, okay? I could also make another median from A and draw to its opposite side. And that point there would be, call it M2 for midpoint number 2. And yet there's another one, right? If you start at C, you could do that yourself. And the third one is altitude of a triangle. So it's a line segment drawn from the vertex again of a triangle such that it is perpendicular to the opposite side. So be careful now. So this time you have a vertex, and to its opposite side, you're going to have a right angle. Not the midpoint this time. You're going to have a right angle. Okay, so that's altitude of a triangle. So let's look at an example here to draw inferences from the diagram. So in the following diagram, it is given that C is the midpoint of AB. What conclusions can you draw from this given? All right, I hope you had some time to think. So of course, we have segment AC is congruent to segment CB. That's one notation you could use. Or you can use the other notation, which is saying AC is equal to CB. So notice the difference in those two, okay? And the reason I can say that is because C is the midpoint. So every time you want to look at the word there, that gives you a clue. Okay, so the word here is midpoint, and you have to know what midpoint means and what can you tell based on that given. Here's another example. All right, so in this example, they're describing the diagram for us, and then they tell us to read the givens and state all the conclusions that we know based on the givens, and then we have to explain our conclusions. So just to make it easier for us to explain, I've used this T-chart to have statements on one side and reasons on the other side. First, the given tells us that BE bisects angle ABC. So for right there, we can say something, right? Bisects, that word, we know what that word is. Okay, it means to split an angle in half. So that means you need to locate angle ABC. Remember, use the vertex to find the angle. So there's my angle ABC. That means that now I have created two angles. I've created this angle, and I've created this angle, okay? So those two angles are now going to be equal because we've cut them in half using ray BE. So here we go. So angle ABE is equal to angle EBC. And what's the reason for that? Well, that's just using the definition, right? And you can can simplify using this notation, shorthand definition of angle bisector, okay? All right, let's look at number 2 so we can cross this out. Number 2 says AD is the median drawn to BC. Recall what median was. You can go back and check what median was. So notice that the median of a triangle, right? It creates a midpoint. So it's drawn from the vertex to the midpoint. So that means that we must have a midpoint somewhere. So here we're given that AD is a median drawn to BC. So AD here is the median drawn to BC. That means that point D is a midpoint. And that's how you would write that, okay? Okay, let's see what we can say now. Well, since D is the midpoint of BC, what conclusion can we now draw? That's right. We can say that BD is congruent to DC, and that's by the definition of a midpoint, okay? So far here, we just used 3 different definitions. Sometimes it's going to be that simple. Sometimes it'll be a little bit more involved, okay? But this is just an introduction. Let's look at our CFU for today. So here is our CFU. We are given that we have 3 points on a line, okay? We are given that we have a perpendicular, okay? We're supposed to answer these 3 questions here and finally decide if we can conclude that these 2 segments are the same. I will see you tomorrow in class. I hope this wasn't too difficult. And we're going. This is the heart of geometry, explaining your reasoning as much as possible.